Travis Gillespie here. Let's take a look at the following problem and see what can be done to solve it. And the question says, what is the domain of the function shown on the graph? Well, let's first start by defining what domain actually means. What are they talking about here? Well, the domain, typically its values are sets of input, and these input values spit out an output value. They provide an output. Another way to think of it is the domain is typically a set of independent values. When looking at graphs or data, your independent values, one example would be time. Time's an independent value. So what typically happens is when you're plotting the graph for time or taking data, you would say at value x, or at this time, the x value will spit out a y value, an output. And then at a later time x, a different y value is spit out. So how do we go ahead, how do we write this out? Well, let's look at the first plot here, -2, 2. I'm going to provide a number line. And remember, when dealing with the domain, you're typically dealing with an x value. So I'm not even going to worry about the +2, which is a y value. All I have to do is focus on the x value. Well, the x value for this point is -2. So I'm going to draw an open circle on -2 because I have an open circle here. Now I've got to say, hey, since all values are plotted to the right of this dot, I know that x is moving in a positive direction on the number line. So I know that my arrow is moving in this direction. It's positive. And now I can plot my arrow, and I can say, it's easy to see now, x is greater than -2. Or another way to say it is -2 is less than x. Let's plot the other point. How can we represent the domain for the second point? And that point is at 6, -4. Again, since only dealing with domain or x values, you don't even have to focus or worry about the y. The y is a -4. All you have to focus on is the x value, which is +6. So plot +6, and this time you see this is a closed circle. We'll draw a closed circle, and since all x values that are plotted are to the left of 6, I'm going to draw my, that's the school bell there. I'm going to draw my arrow at values less than 6. And now I can see that, hey, x is less than or equal because this is a closed circle. X is less than or equal to +6, or another way of writing this is 6 is greater than or equal to x. How do I represent both of these at the same time? How do I know that both of these occur at the same time, both inequalities? And one way to do it, I'm just going to circle. -2 is less than x, and x is less than or equal to 6. And looking back at the original graph, I can rewrite the inequality as an AND statement. -2 less than x, and x less than or equal to 6. Thank you.